It has now been almost a week and a half since the synthesis of this alum solution, which you can see has yet to form crystals. One possible reason for the lack of crystals is that the temperature of the room is not high enough for a significant amount of the water to evaporate, or that the air is already too humid or saturated with water to evaporate the water from the vial. The water needs to evaporate in order for the crystals to begin to form in the vial. To create the alum solution, we started with 1.02 grams of aluminum foil. To calculate the theoretical yield, I used stoichiometry and the amount of each of the reactants used to see which of the reactants is limiting in the reaction. The number of moles of the limiting reactant represents the amount of moles of that chemical that could be present in the crystal. The reactants that were measured were 1.02 grams of solid aluminum, 50 milliliters of 4 molar potassium hydroxide, and 25 milliliters of 9 molar sulfuric acid. By dividing the mass of aluminum by the molar mass, it was found that we used 0.039 moles of aluminum for the synthesis of alum. Then, from the given molarity and measured volume of the potassium hydroxide and sulfuric acid, I calculated 0.2 moles of potassium hydroxide and 0.225 moles of sulfuric acid were present. Looking at the product of all the reactions that take place, 1 mole of alum consists of 1 mole of potassium, 1 mole of aluminum, and 2 moles of sulfate. This confirms that the solid alumina is the limiting reactant because it is present in the lowest quantity. This means that the reaction should produce 0.039 moles of alum, which is equivalent to 18.4 grams. This is the theoretical yield of the reaction. When the alum salt produced in lab was weighed, the weight was 16.71 grams. This is the actual yield of the reaction. To calculate the percent yield, the actual yield is divided by the theoretical yield, and then that decimal is multiplied by 100 to get a percentage. For this experiment, the percent yield was calculated to be 90.8%. One part of the procedure that may have contributed to not having a 100% yield is the initial filtration of the solution after the solid aluminum was dissolved in potassium hydroxide. Some of the aluminum may have not dissolved fully in solution and then may have been filtered out. This would lead to that filtered aluminum not being part of the alum crystals made later on in the experiment. A second source of error that would lead to a less than 100% yield would be the collection of alum residue on the multiple containers used to hold solution throughout the experiment. This probably doesn't account for a large loss in yield, but it could have a small effect.